Well, now coming back to the motivation behind the LCE event system, um, the communication over the distributed applications was always it's kind of a major challenge in the industry. How you advertise information. um, LCE was actually designed specifically to address this problem. Like basically you can solve this problem couple of ways. Number one is a request reply approach where you will poll for the information. The other one is a publish subscribe scenario, and LCE actually falls under the second category of publishing an information. And subscribers who basically want to receive the information will create subscriptions and get the event notifications. Well, this is the programming model for the complex events. One of the major design goal for complex events was to make the programming model much simpler, simpler to the extent of like create a component and make a method call on that component, and voila, your interested subscribers should get those event notifications. So if it should be as simple as like in a VB script or in a VB in a scripting language, you should be able to create an object and assume that that object is a stock ticker stock event notification object, and you do a method call on that, and you are interested basically registered subscribers should be able to receive the event notifications. uh, Talking about the overall architecture of the complex events, so complex events has a component called a publisher. A publisher could be anybody, like could be ranging from a VB script, a C++ application, from a COM object, etc. Anything who can publish information. So that's a publisher, and that publisher will create a component called event class, which are obviously defined. The metadata will be defined by the publisher, by the developer, and stored in the event system. And you should be able to create that event class, and he will make a method call on that event class, and this event class will replicate all this method class to the registered set of subscribers. So we have a publisher, we have event class, and a subscriber, and of course a subscription. These subscriptions as well as event classes are created using the component services snap-in, or you can use COM admin API interfaces, and these are basically stored in the complex event store. Complex event store is nothing but complex catalog, and you'll be having a NT service which runs as the complex event service, which manages the storing as well as the retrieval of the event classes and subscriptions and distributing it across the subscribers when an interesting event happens. So now coming to the specifics, like what is an event class? Well, event class acts as an intermediate component that sits between a publisher and a set of subscribers. And as a developer, you will define the attributes that identifies the event class. Like you specify how you identify this event class with a GUID. It could be we call it as a class ID, and of course the friendly name of the event class called as a prog ID. And we already discussed that RTM event class supports multiple firing interfaces, so we should be able to specify a type library which describes the firing interfaces, and if it required, or if you are interested, you can specify the publisher ID on this event class. So as such, this event class requires a very minimal coding effort on part of the developer, basically to define these attributes on this event class. And you have to specify a DLL name, which the DLL that basically exports a DLL register server. The whole purpose is to associate the class ID and the prog ID on that event class, how you are going to associate, and also the TLB that is required that depicts the firing interfaces. So you specify these using complex admin API or the GUI, and you store it, it will get stored. From then onwards, you'll be able to create this event class and be able to call any methods belonging to those firing interfaces. There is no need for you to implement those methods on the event class. Complex event system, basically when you creates this event class, reads a type library, manufactures a vtable, and makes appropriate call on the registered subscribers. as with our old classic com connection point model, event class, complex event system support arbitrary interfaces. What I mean by arbitrary interfaces is you can have any interface as your firing interface. It's not a must that actually there is a defined interface, only you have to use that as the firing interface. Okay, we'll take an example in a stock market scenario where you have a lot of stock price changing, new stock getting added, those kind of stuff. We'll abstract with an interface called iStock events. And let's say this iStock events interface has 4 interface methods, like the stock price change, new stock, stock symbol change, and there is a Dow Jones update. And you can subscribe to the method level. You can actually subscribe that I'll want notification only when there is a stock price change, so that you will subscribe to this stock price change method. And each method can have 0 to n subscriptions. And of course, as a subscriber, when you want to receive notification on this event method, you have to implement this method. So this is the code for registering an event class with the complex event system. At this point, I want to make a note that actually event class is treated as a complex configured component. So it has to be registered under an application. So you create this is the code, you will do a create object on the admin catalog and get a collection for applications, and you create an application called demo app. And under this demo app, we will create our event class. So the second line, the third line, admin.install event class in this slide is the one that actually installs the event class under this demo app application. So this d:\new proc zoo event class debug zoo event class .dll contains the type library information, as well as it exports the DLL register server. If you want, you can actually specify a separate TLB file and can specify the TLB file name as the third parameter of this function call. Maybe you should be able to work. In this case, this DLL also exports the type library of the firing interfaces, and then you call the populate. And when you call this install event class function, basically the following event class attributes are set, like the event class ID, event class name, and the type library path, where the type library is located. The other properties like firing in parallel, setting up the publisher filter class ID, those kind of things you have to do by getting a pointer to this specific event class object. So this you can do with the admin API itself. So you go and get the application collection and locate that specific event class component and set the value of the other properties. Like here in our case, here it's event obj is that specific event class component. We specify the name, properties like the fire in parallel, allow in-proc subscribers, etc., and do a save changes on that collection. You have registered the event class. Well, so if you recollect the architecture, like we had event class, a publisher, and a subscription, etc. So now we talk about the subscription. This subscription acts as a wiring between your individual event class component and the subscribers that are basically interested in receiving the messages. So typically, a subscription takes the following properties, like it has a unique ID, it takes a subscriber basically interested in. So we will discuss what are all the required properties and the optional properties on the subscription. So as I told, a subscription is a relation composed of an event class interface. What I mean the event class interface is the firing interface which you basically want. If you want, you can specify a firing interface, or if you want, you specify an event class interface. If you specify an event class interface and you specify the firing interface as null, it means that you are interested basically in all the firing interfaces of that event class. And if you want, you can specify a method name, and if you specify the method name as null, it means that all the methods of that specific interface you have mentioned. And of course the subscriber who basically you are writing the subscription for. This subscriber could be a class ID, or it could be a moniker, or it could be an interface pointer. And this defines actually the type of subscription you are basically registering for. We have two types of subscription. The one is we call it as a persistent subscription, the other one is a transient subscription. Persistent subscription is basically persisted, and it takes a property called subscriber class ID with it. And what it means is that when you specify the subscription and an event is fired, each and every time your component will be instantiated and a method call will be made on that component. The other subscription is a transient subscription, where in that case you will create that subscriber, and you will specify the subscriber interface, that is the INON star pointer of that running instance of the subscriber. And from whenever an event notification happens, you will get an event notification on that instance of that subscriber through that subscription. We call that subscription as a transient subscription. And if you want, you can actually go and check the property called a subscriber moniker property, and that's how you're going to call a moniker. How we are also actually making use of the moniker property using the UI, where in the UI, once you create a subscription, you go ahead and select the checkbox called queued, so that specific component will be called via QC. So we have discussed the okay, now it's the required subscription properties. The first one being the subscription ID, which is a GUID that identifies uniquely this subscription. And of course, a subscriber, as we have discussed, it has to be it has to be either a subscriber class ID or a subscriber moniker or a subscriber interface. It cannot be all at the same time. And a valid combination of the publisher ID, event class ID, the interface ID, or the method name. And these are the the other subscription properties. If you want, you can specify. We often do get a question like whether subscriptions or events are basically remotable. Yes, they are. You specify a mission name in that subscription. So whenever an event happens, your component on that specific machine will be instantiated, and the method will be delivered on that component. So that's why you specify a machine name. And then there is a decorative property called a publisher properties, which is basically a iProperty bag implementation that takes a name value pair that is left to the developer to put whatever he or she basically interested in, so it can be later used for filtering purposes. And the new property called filter criteria, it's an RTM property, and what I mean is it's RTM release. It's coming with RTM release, where you will specify the query string, like then the complex event system validates that query string and makes a decision whether this subscription should be called or not. And the other interesting thing is a per user username combination. So this is what we call as a per user subscription, where often you want to get even notifications when a specific user is logged on. If that's the case, then you can go and set this per user flag to be true and give the username. And from then onwards, actually only if that specific user is logged on, you will get even notifications from that specific publisher. Okay, now comes, most publisher subscriber systems, even say our classic COM connection points, doesn't delineate between what the subscriber is and who is a subscription builder is. If you remember how we do, we create a subscription in our COM connection points, is actually we will we will hand over a pointer to the self through the advice call. So that action we can call it as a subscription building. So in that case, a subscriber is basically the subscription builder. So here in complex event system, you can have a subscription builders entirely different from a subscribers. So this actually helps you assume that you are writing an application, and in that application installation time, you can actually create subscriptions. So it's kind of entirely loosely coupled from it's not dependent that the publisher or the subscriber has to be up and running. And so a subscriber is basically a component which receives an event call, and a subscription builder is just an entity that registers the subscriber to receive the event. Of course, if you want, your subscriber could be a subscription builder also. So the question for who builds subscriptions: a publisher, if you want, a subscriber, an admin using the component services snap-in, or it could be using a complex admin UI. So the answer would be typically anyone who has enough authority to create subscription would be able to create this subscription. So this is the code to create a subscription. This code talks about how to create subscription for a complex configured component.
Again, if there's anybody who needs to ask a question to Senthil, please send your question to count99@microsoft.com.
Cool. Thanks, Ulrich. So I will try to correlate this. Okay, persistent subscription will be created for is basically for a complex configured component. You create a subscription for a complex configured component, thus we call it as a persistent subscription. And a transient subscription is actually for a running component. It could be a complex configured component, or it could be a legacy component where you instantiate and hand over a pointer to yourself as a subscriber interface attribute in your subscription. So again, now we are actually showing how to create. Okay, I'm creating an application called demo sub using a com admin catalog, and then I'm getting a components collection, and I'm installing a component called zoosubscriber.dll. So this becomes a complex configured component, and I'm going to create a subscription for this specific complex configured component. And so I'm getting a subscriptions collection for this specific component, and so this is a property like the subscriptions for component. So you get a subscription collection, and you specify the value like the event class ID, the enable, the name, publisher ID, whatever you want to set, and then call a save changes on this collection, so you'll be able to save it. So giving a summary of the subscription, subscriptions are basically two types. We can take three types also. A persistent subscription, which will be basically persisted and it will survive system reboots, system failures, etc. And a transient subscription, and a per user subscription, which falls under the persistent subscription category. No, you can have a per user subscription, basically both a persistent as well as a transient subscription. And subscriptions now in complex event system are basically more expressive as objects when compared to object pointers, like in our connection point scenario. And subscriptions are stored in complex events, and subscriptions are independent of publisher. There is not a requirement, unless there is a transient subscription, that neither a publisher nor a subscriber should be up and running to create a subscription and store it. And also subscriptions can be shared among publishers. It could be multiple instances of the same component, or it could be two different instances of two different components, as long as they create a same event class and do a method call on it. If you have a subscription for a specific complex configured component which also has an event class ID on it, you'll be able to get notification from those two different publishers. So the subscriptions are basically shared. Well, the third important ingredient of the event system is the complex event store. So what complex event store? We're making use of the complex catalog itself of the complex event store. So it basically stores the event classes and the subscriptions. So you could either use the complex services it's component services explorer, or the complex API to access the store, basically to retrieve an event class, to create an event class, to delete an event class, all blah 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 related to it. And a cool thing about the complex event store is that it publishes predefined meta events, like it publishes events for event class addition, updation, removal, subscription addition, updation, removal. And what as a subscriber you should do to get notification for these meta events is you have to implement an interface called iEvent object change in your subscriber, and from then on you will be able to get notification happening in the store with respect to public event class and subscription updation and modification. So this diagram talks about how firing happens. This resembles overall to the overall architecture we already discussed earlier. There is a publisher component. You create a already installed event class component and make a method call on it. So complex event system goes and reads the event class type library and creates this component, and also it goes and checks the event store and picks up the appropriate subscriptions, and when a method call is made, it's going to deliver the same event to the installed interested subscribers. And we won't be having a demo today. We'll be upgrading it, and we'll be putting it in a platform SDK. You'll be able to get by the end of this month. So so far we have discussed about the basic firing in complex events. Now taking the advanced topics, we are going to discuss about event filtering using publisher filtering and parameterist filtering and the parallel firing and composition with other complex features. Going back to a scenario of say firing events whenever stock price changes, most of the subscribers won't be interested for all the stock price changes. I mean, there will be a specific subscriber who wants to be notified only when there is a Microsoft stock price changes. So in that case, you have to have filtering. You can actually do this in a couple of ways. You can have a publisher side filtering, or you can have a parameterized filtering. So publisher side filtering basically requires you to write a filter component, which is it's a COM component, and that COM component does that filtering logic for you. Or you can do parameterized filtering, where you have to specify the query criteria on the subscription itself. So complex event system does filtering for you during the firing times. This first one, the declarative filtering and the runtime filtering, they too fall under the publisher filter category, where okay, let's talk about the declarative filtering. In declarative filtering, you will specify a class ID of the filter component using an attribute called multi-filter publisher class ID, and this component should implement the firing interfaces which you basically want to filter for, and also has to implement an interface called an I multi-publisher filter. So what happens is it goes and gets persisted in the storage, and when you create create an event class using a script or using a co-create instance, this component gets created by the complex event system, and during this creation time, event system goes and checks whether this attribute is selected. When this attribute is set, it goes and creates this component and calls an initialize method on the predefined interface called I multi-publisher filter, and in that interface it hands over, in that method call it hands over a pointer to an interface through which you can get a event subscription collection, that is a self-updating event subscription collection, which you basically make use of filtering, may make use when actual method call come into picture. So when the actual method call happens, event system detects if there is a filter installed. So if there is a filter installed, instead of picking up the subscriptions and doing their firing, it actually calls a method called prepare to fire on that component, and in that method call it hands over an interface called iFiring control, and as a publisher filter you have to store that firing control interface, and then it makes the actual method call on that filter component. Now you have firing control interface as well as the self-updating subscriptions collection. So you have to make a call whether you want to call specifically subscription or not. So you basically loop through that subscription collection and decide on individual subscription basis whether this subscription should be called or not, and call the subscription to that firing interface. So that's how a declarative filtering works. A runtime filtering is something like when after you create an event class, you can get QI for an interface called iEvent control, and you can and you have to specify the filter INON star. In case of runtime filtering, you have to create your own filter and then hand it over to the event system, as opposed in declarative filtering where the event system will create the filter for you. And again, the process is the same as I have discussed in declarative filtering. So these two base set as an attribute, or you do something with the event class. And next comes parameterized filtering. This you specify as a query, which is basically a beaster, which does a which is a beaster, the query string, and it of course does filtering on using a wchat star and a long, and you specify it as a attribute in your subscription and you persist it. So when you make a method call, complex event system validates its query and decides whether to make to call that subscription or not. So if it is validated that you can call, it goes ahead and makes a method call on that component, or else it won't. So this diagram talks about the declarative and runtime filtering for the publisher filter scenario. Like say there is an event class, you create an event class, and event system detects that it has an event filter, so it hands over the subscription collection and as well as ciphering control interface. So you loop through that subscription collection and decide whether you want to make a call to that specific subscription or not, and that's how you control it. The other cool thing about the RTM release of LCE is you have parallel firing. In case of a serial firing, assume that you have 3 subscribers, 3 subscriptions, and how it happens serially. Like first it calls the subscription 1, basically the subscriber 1, and when the subscriber 1 is done with its processing, the control goes back to the subscriber 2 and subscriber 3, and then it returns back to the event system. So what happens for the subscriber 3 is it will wait. It won't get the event immediately. It has to wait till subscriber 1 and subscriber 2 processes its information, as opposed to a parallel firing, which is just it's an attribute. We are going to just check. It's a bool flag which you will check using the admin services explorer. And if it is set, so when a method call is made, all the event classes, all the subscriptions are basically called parallelly. Even in this case, event class will block till the till the last subscriber completes its processing. So next, composing with the other complex features. Qt components is kind of a major thing that you can compose with LCE for. So how you do it is you can go and select, since event class is a complex configured component, you can go ahead and select the Qt attribute on that event class, so your event class won't basically block. You make a method call on that event class, it will be converted as a QC call and you will return immediately. If you want, you can select your subscribers to be queued also. It's very simple. You go and select on the subscription, you go ahead and select the queued attribute. Your subscriber is going to be called using QC. So in that case, you won't be blocking. And of course, other all complex features like your role-based security is going to get free. Whatever the role-based security is applicable for other complex components, it's exactly the same. It's applicable to the LCE components also, like your event class. And deployment is made much simpler using the complex admin UI. And of course, you can have a transaction support on the event class. If you want, you can go ahead and check the transaction flag using the UI. So this is how the queuable event class which I have discussed. So this event class, that the small rectangular block depicts a queue. So a cool scenario would be like if you want, you can select the event class to be queued and also select a parallel firing, set the parallel firing flag on that event class. So whenever the publisher makes a call in this event class, it's going to return immediately, and event class will fire all the events to the subscriber parallelly. And this is the other case of a queuable subscriber, where your subscribers are basically queued. So these two rectangular blocks are subscribers which won't basically block till block on their processing times. Well, talking about the current customers. Thanks, Eric. We have IE5 and Sense. Sense is something like called systems event notification services, basically made use of by IE5 to publish events like login, logout, network connect, disconnect, plug and play, shell start, and etc. So they have a bunch of event classes already been written. And Sync Manager is another customer. They makes use of Sense to publish events, and Complex itself is a major customer for LCE. All Complex components do a fire, debug, trace events using Complex events.